Hi everybody, welcome back. Today we're going to look at section 5.4, which is on differentiation of exponential functions. So today we're going to look at how we take the derivative of an exponential function, mostly with base e, because those are typically the ones we use more with growth and decay problems in real life, but also we'll look at exponential functions with other bases that are not e. So today we're just going to look at how we take the derivatives of functions that are given to us. So let's look at the rules for those. So for e to the x, okay, these are when you have a base of e. One of two things are going to happen. You're just going to be asked to find the derivative of e to the x, okay, which is part b. We'll start with that. But if you're finding the derivative of just e to the x, it's real easy because the derivative is e to the x, exactly what's there. However, typically the x has another function up there. So it's not going to look like e to the x, it'll look like e to some function, okay? So e to some other term up here that's an actual function that has another x in it. So the derivative of that is always going to be e to whatever you have. Okay, so that always is the start. You take the derivative of e to the anything is e to the anything. But then when that exponent is another function, you have to then multiply it by the derivative of that. Okay, so we'll go through that. So it's pretty easy. These are not too difficult rules, but what seems to throw some of you off is this part right here. So we'll go through that and make sure we're clear going through these examples. Then pretty much the same thing is going to happen when you have a different base. So notice instead of e to the gx and e to the x in parts a and b here, we have b to the gx and b to the x. So b represents any other number besides e. Remember, e is just a number. So these are other bases besides e. So you're still going to do the same thing except for the start. If the base is not e, when you start a derivative, you'll always start with the natural log of whatever that base is. Then the rest of it is just like above. Okay, so you're going to take the natural log of b, and then the derivative of this is the same thing times the derivative of the exponent. So it's just like what we did here, except at the front, we're going to have the natural log of b. And the same thing of b to the x. The derivative of b to the x is not just b to the x. You're going to tack on that natural log of b in the front. Okay, so they're very similar as far as what we do. The only difference, like I said, is this natural log of the base that goes in front. All right, so let's do some practice problems with these and see how that works. So we're going to start first. These first few pages are going to be e to the x. Okay, so number 1 on your derivatives. All right, so part A says we're finding the first derivative, y equals e to the 2x. So the derivative of e to the anything is e to the anything. So that's how you start. Then, if this exponent is anything other than x, you have to multiply by the derivative of 2x. Well, the derivative of 2x is just 2. Okay, that's fine to leave it like that. If you want to put the 2 out front, that's perfectly okay. Okay, sometimes you'll notice that you have to simplify to find answers. Sometimes you don't have to. So it just kind of depends on the problem. Okay. All right, so that was number 1. That's that rule 1A. Okay. All right, let's look at B. B is y equals e to the x. Okay, so the derivative of e to the anything is e to the anything. And you're supposed to multiply by the derivative of this. Well, since that's just x, derivative of x is 1, so I don't have to do that. So that's why the derivative on your formula sheet for part B is just that. You can do times 1, but you really don't need to. Okay? So that's the nice easy one. Derivative of e to the x is e to the x. All right, now look at C and D. You have a constant in front, also E, but that's not up here right now. But remember, constants are part of your answer. So when we look at the derivative for the function in part C, 3 times e to the 2x squared. So 3 is going to stay right there because you're going to multiply whatever you get times that constant. So you're really just looking at the derivative of e to the 2x squared. Well, the derivative of e to the 2x squared is e to the 2x squared, and then times, what is the derivative of 2x squared? That would be 4x. And that's not part of the exponent. That goes in the base, okay? Nothing, your exponent will not change in your answer. What you're multiplying by goes in the base. So the derivative of the exponent comes down as part of the base. So that is your derivative. Okay, if you want to clean it up a little bit, we can multiply the 3 times the 4 and get 12, put the x out front, and then e to the 2x squared like that. That's how you would simplify that. So it's good to practice simplifying in case we need to use these problems later on. All right, D, exactly like what we just did. Okay, so our function is 5e to the 2x squared plus x. So 5 is a constant. It's going to stay there. Now, the derivative of e to the anything is e to the anything. So that's the derivative. But then we got to multiply by the derivative of 2x squared plus x. So just take that as individual power rules. So the derivative of 2x squared is 2 times 2, that's 4x. And the derivative of x is 1. So 4x plus 1. Right, that's the derivative of the exponent. All right, so again, this is fine to leave it, but if we're going to clean it up, really, I mean, you can bring the 4x out front. You could write it this way. Usually you put the e at the end, but you don't have to. But that's a lot of the ways you're going to see it. Okay? So usually the other variables go out front of the e. All right, so part e again is 1/2, that's a constant, and then e to the square root of x is your function. So the derivative, leave the 1/2 there. Derivative of e to the anything is e to the anything times, and now we need the derivative of the square root of x. Remember the square root of x? That's x to the 1/2, right? So the derivative of that is 1/2 x to the negative 1/2. You can leave it like that, or you can bring that down to the bottom. A lot of times we write it this way. Same thing. Okay, so however you want to write right now, you're going to multiply either by this or this, whichever you feel most comfortable with. So I'm going to write 1/2 square root of x. And that's the derivative of the exponent. All right, now if you want to combine this, all of this is in the bottom, so we could write 1/4 square root of x times e to the square root of x. We could simplify it that way. Okay? You can actually write the e to the square root of x in the top if you want. This is the same thing as this. Okay? Either of those is fine. Okay? So again, it's hard to tell you guys how to simplify because again, if it's a multiple choice question, whoever's making that up is going to write it the way they feel it should be simplified. For me, you know, as long as I see that you did it right, that's what's most important. You do need to know how to simplify it in case, again, you have to find like a tangent line or something where you're using the function. So just take your time and practice those simplifying steps. All right, now f is not a constant here. In function g of x, it's x times e of x. So this now becomes a product rule. I didn't have to do a product rule when it's just a constant, okay? Derivative of a constant would be 0, so there's no point in doing a product rule here. You could, but you don't need to, okay? So for function g of x, however, this is a product, and I do have to do the product rule. I can't get around it on this one. So remember your product rule, okay? Product rule says the first function times the derivative of the second. So x is your first function, and then the derivative of e to the x is just e to the x, right? Plus, and then you're going to do the second function, e to the x, times the derivative of the first function. The derivative of x is 1. Okay? And if you want to clean that up, not a whole lot to do with that one. Okay? Now, could you factor? Sure. Okay, I mean, yes, you can factor out an e to the x. That might be the way an answer is written. You factor out an e to the x, you would get that. That's a perfectly good way to write your answer. Okay, so it just again depends on what you're looking for. So you may or may not have to go too far in simplifying, and in other problems you may need to. All right, moving on. So this is just all about practicing this so you guys can try the homework on your own. Okay, now look at part G. G of x is negative 2 times e. So that's a constant. So I don't need the product rule here. So I'm just going to leave that negative 2. All right, and now I'm going to take the derivative of e to the anything is e to that anything. And then times, on the bottom, we're going to do the derivative of the exponent. So what is the derivative of 2x cubed? That would be 6x squared. And the derivative of 5 is nothing, right? So, all right, so there's your derivative. Clean that up if you'd like. Negative 12x squared e to the 2x cubed plus 5. Okay? So again, make sure you're just doing those steps right. All right, part H. Definitely a product rule. Okay? So e to the x, that has an x in it. It's not a constant there. It's got x times the natural log of x plus 4. So now we're going back and bringing in our natural log formulas that we did in the last section. So this is a product rule. So remember the product rule, we start with just the first function, and then we're going to do times the derivative of the second function. So the derivative of natural log, remember, is the derivative of the inside, 1, over whatever the natural log is. Okay, so it's the derivative of the function, g of x, and then g of x in the bottom. All right, plus, and now we're going to do the second function, natural log of x plus 4. Okay, that's the second function, times the derivative of the first function. So the derivative of e to the x is e to the x. Okay? I'm not really going to clean that up. There's not a whole lot I can do other than put this in the numerator, which you could. This, you could put the e to the x out front. I'm just going to leave that one alone for now. I don't see much use in simplifying that like that. Okay? All right, part I. This would be a quotient rule, right? We got a division problem. So let's see how that works. So quotient rule is we're going to start with the bottom function, okay, times the derivative of the top function. Derivative of e to the x is just e to the x, minus the top function, e to the x, times the derivative of the bottom. Well, what is the derivative of e to the x? E to the x. And the derivative of negative 1 is just 0. So there's your derivative of the bottom. And then we have to take the bottom squared. Okay. So again, this got a lot of e to the x, but this would be good to simplify. So I'm going to bring that e to the x out front here. Now, this is good. If you're doing e to the x times e to the x, remember you multiply the numbers out front. So 1 times 1 is 1. You're not going to get a 2 e to the x. So it's at e, and then you add your exponents. So 1x plus 1x is 2x. So that's what that would simplify to. I would just leave it like that. Okay? Just kind of depends again, but so you can keep going quite a bit, but we're just going to keep it like that. Okay? Because I mean, I could, if I multiplied this, I get e to the 2x. That would cancel with that. So I'd actually just have a negative e to the x in the top. So again, you guys can, it just depends on what you're doing. But, that could go through as well. So I don't know if you see that, but e to the x times e to the x would be e to the 2x. E to the x times negative 1 would be negative e to the x. So this e to the 2x would cancel with that one. You could do that, okay? But again, we're not using these right now, so it's okay. And it's perfectly fine to leave it just like we did in the top. Okay? All right. Finally made it to number 2. Number 2 says find the first and second derivatives of this function. All right, so first derivative, I'm going to use our power rule. So the derivative of negative 6x squared, that would be negative 12x. And then minus 5, and then the derivative of e to the x is e to the x. Okay, and then the derivative of the exponent is just 1, so I don't need to do that. So there's my first derivative. Then it asks you to find the second derivative. So the derivative of negative 12x would be negative 12. And again, the derivative of negative 5 e to the x is negative 5 e to the x. So there's your first and second derivatives. Okay. Sometimes, if you're asked to find a second derivative, you might have to clean up the first one. So, like we're probably going to have to do in this next problem. But this one did not need us to do that. All right, so let's look at number 3. First and second derivatives again. Product rule. 2x cubed times e to the 2x plus 1. So we have to do a product rule for the first derivative. Okay, so first derivative, product rule, we're going to start with the first function, 2x cubed, times the derivative of the second function. So the derivative of e to the 2x plus 1 is e to the 2x plus 1, times the derivative of the exponent, which would be 2. Derivative of 2x is 2, plus, then we're going to do the second function, e to the 2x plus 1, times the derivative of the first function. Derivative of 2x cubed would be 6x squared. Okay? All right, so here's a case where I definitely want to clean this up because I do not want to take the second derivative of this. This looks like a big mess, right? So let's look at cleaning that up. So first off, on the first term, I can multiply the 2 out here. So that's 4x cubed e to the 2x plus 1 plus, and here I can do 6x squared e to the 2x plus 1. Okay? All right, so I can leave it like this. I can do some factoring. I guess if I factor out, I don't know which would be easier. I'm just thinking as I'm looking, but if I factor out an e to the 2x plus 1, I know I can factor out more than that. I'm just thinking right now. Okay, so if I just factor that out, I think that would be easier to leave it like this, because if you factored out a 2x squared here, then this is a product rule. So I think this would be easier, because if I do a product rule here, the derivative of this is easy, right? It's just a power rule. And then the derivative of that is easy. So I'm thinking I'm going to leave it like that to do the second derivative. I just did that by looking at the fact that I didn't want to have to do a too hard of a product rule. Okay. So again, those of you that are thinking, why didn't I factor out a 2x squared and then factor that? So that's really the common denominator, and that would leave me 2x plus 3, right? Okay. So I don't want to do this derivative because the derivative of this is a product rule, and then I got that. So I got 2 product rules going on here. So I don't want to do that. This is much easier just to do this kind of a derivative. 1 product rule. Okay? So that's why I did not want to do that. All right, so second derivative. Okay, so we're going to start with the first, it's another product rule. So start with the first function times the derivative of the second. So the derivative of this is 12x squared plus 12x plus, and then the second function, 4x cubed plus 6x squared times the derivative of the first. So the derivative of e to the 2x plus 1 is e to the 2x plus 1 times the derivative of the exponent, So the derivative of 2x is 2. Okay. Now, I don't know. I don't see much to simplify here. I think I'm just going to leave it like that. I mean, I can't do anything here. I can factor out that 12. I mean, I can multiply these guys by 2, but again, we're not looking at any multiple choice questions. We're trying to figure out. So we will just leave it be like that. Okay? All right. You know, typically we're not going to ask you to simplify really hard problems. More on these, we want to see that you know the rules. Okay? So we're just practicing the rules. All right. Now, on this page, we're looking at other exponential functions. So the base is no longer e. Okay, so this is that capital B from the first page. So everything is the same except you have to take the natural log of the base. Okay, so the derivative of 2 to the x, since the base is not e, you always start with the natural log of the base. Then it becomes just like before. If it was e to the x, the derivative of any exponential function is the exponential function. And then if there was a function up here, I would have to multiply by the derivative of that. But the derivative of x is just 1. So that's what that looks like. Okay? That is your derivative. All right. Part B, constant times an exponential. If it's a constant, it's part of your answer. So 3 times. Okay, now this is not e, so we're going to start with the natural log of 41. Got to have the natural log of the base. Then we do the derivative of the exponential function is the exponential function, and then times the derivative of the exponent, which is just 1. Okay, and that's it. You cannot multiply 41 times 3, and natural log, you can't do anything to that number. You can't multiply 3 times 41 here because you have to raise 41 to the power first. So you can't do anything with those 3. Those are 3 unique numbers and they have to stay separated. Okay? That's a common mistake a lot of you guys do, like this. That is not 6 to the x. A lot of students do that, but that is not correct because you cannot multiply before you do the exponents, right? Order of operations, so you have to raise 3 to the x power and then multiply by 2. So you cannot multiply that, and the same thing goes for logs. All right, part C is very similar to B, except we have x squared up here. Okay, so constant stays in the answer. Base is not e, so we've got to have that natural log of the base in there. And now we'll do the derivative of the exponential function is the exponential function times the derivative of the exponent. So the derivative of x squared is 2x. And remember, that goes in the base. It does not go in the exponent. Okay, the exponent will never change on you in your answer. Now you could, in this case, do 3 times 2x. Those are just numbers, so that would be okay. To write it like that. Okay, because that is multiplication. That's fine. You can leave it like it's the very first line. That's okay too. Okay. All right. I don't want to confuse you too much with all that simplifying, so that's why it's fine to leave it. All right. Now number 5 says find a formula for g prime of x and determine the slope at g prime of 2. So this is one you may or may not need to simplify because you got to plug 2 in and work it out, but we'll see what we get. So first we're going to find the derivative. All right, again, this is 4 times e to the 5x cubed minus 9, so that's a constant, so we don't need to do the product rule. That's just part of the answer. Derivative of e to the anything is e to the anything, so e to the 5x cubed minus 9. And then times, down at the bottom, we're going to do the derivative of the exponent. So the derivative of 5x cubed is 15x squared. And the derivative of negative 9 is 0, so that's that. All right, so since I've got to plug 2 in here, I mean, I could do it just now, but I'm going to go ahead and simplify it just a bit. Not a whole lot to simplify. I'm going to do 4 times 15, which is 60. Bring the x squared out front, and then e to the 5x cubed minus 9. Okay? And so now it asks me to find the slope when x is 2. Okay? So that means I'm plugging in 2 here. So just take your time, use your calculator. So 60 times 2 squared, and then times e to the 5 times 2 cubed minus 9. Okay, so that's 60 times 4. And then e will be to the, let's see, 2 to the third is 8. 8 times 5 is 40. 40 minus 9 would be 31. And that I'm going to put in my calculator. Okay. So 60 times 4 times e to the 31. Yeah, that's a really big number. I'm just going to leave e in there then, because this means I got to move that decimal 15 places. So that's a huge, huge number, which obviously would be with such a big exponent. So let's just multiply 60 times 4 and call it 240 e to the 31. Knowing that that's a humongously big number, we'll leave it that way. Okay. All right. So again, remember, we haven't really had a lot of problems where you've had scientific notation. But if that's a positive number, that means you move that decimal 15 places to the right. If that was a negative number, you'd move it however many places to the left. So 1, 2, 3, 4, 5, 6, 7, 8. We've got to add 7 more zeros. That would be that number, which is huge. Okay? All right. Hopefully we won't get such a big number for number 6, since we have to write the equation of a tangent line. All right, so number 6, we're going to do pretty much the same thing, but we're going to write the equation of the tangent line to this function. Okay, and all they gave us is x equals 1. So remember, to write any equation, you need a point and you need the slope. Okay, so the point, I know x is 1, but typically everything we've done in the past, they give you the point. Here they only gave you x of the point. So remember, where do you find the y value for your point? You would plug 1 into the function. Okay, so to find y for your point, we're going to do f of 1. So we're going to put 1 in the equation. So e to the 5 times 1 minus 5, that's e to the 5 minus 5, e to the 0, and e to the 0 is 1. Anything to the 0 power is 1, so that's your point. Okay? Oop, I don't know why I wrote 0 there. I said 0 too many times. All right, so e to the 0 is 1, so f of 1 is 1. So your point is 1, 1. Write it up there. Okay. All right, so there's your point. Because remember, to find the equation of a tangent line, I have to put it in this. I got to start with the point slope formula. So now I have my point, x1, y1, but what I don't have is the slope. And remember, to find the slope, we just did that up here. You find the derivative and then plug that number into the derivative. So let's find the derivative of e to the 5x minus 5. Okay, so the derivative of e to the anything is e to the anything times the derivative of the exponent. So the derivative of 5x is 5, derivative of negative 5 is 0, so 5. All right, so that gives us 5e to the 5x minus 5. So there's your derivative. Now we can find the slope at 1. Okay, find the slope by plugging in this number into the derivative. So we're going to do 5e to the 5 times 1 minus 5, which is 5e to the 0. right? 5 times 1 is 5. 5 minus 5 is 0. E to the 0 is 1. So 5 times 1 is 5. So there's your slope. Okay, so we did not get that big, huge number like we did in the last problem. Okay, so now we can write the equation of our line. We have our point, we have our slope, so now we're going to do this. So y minus 1 equals 5 times x minus 1, right, using those values. So y minus 1 equals 5x minus 5. Add 1 to both sides, so you get 5x minus 4. And there's your equation of the line, of the tangent line. Okay? Alrighty. Last page, 2 word problems. This first one is a little tricky just because of the function that's given to you, but we're still doing the same thing. So this is just, again, real life applications and what these words mean when you read them, you know, instead of the word derivative, you're going to read about a rate. Remember that rate is your derivatives. So in number 7, it says the population of an unknown bacteria in an experimental culture is estimated by the population function n of x equals 10,900 over 1 plus 49 e to the negative 0.01x. It's not too bad of a function, where x is the number of hours after the experiment begins. How fast is the population changing at the end of 3 hours? So I do not want to put 3 in here, okay? If I put 3 in here, that's going to give me the population. But the question's asking me how fast is it changing? That's a rate, and a rate is a derivative. So I'm going to do what I just did before, find the derivative, then plug 3 into that. The rate is the same thing as the slope. It's the first derivative. So all we have to do is find the derivative, but that's going to be a quotient rule, but not too bad because the numerator is a constant, okay? So quotient rule says you're going to start with the bottom function times the derivative of the top. So the bottom function times the derivative of the top, well, the derivative of the top is 0, minus the top function times the derivative of the bottom. All right, now the bottom, this is a power rule, so the derivative of 1 is 0. So really you're just taking the derivative of this. So that's a constant. So the derivative of 49e to the 0.01x is 49 to the e negative 0.1x. Then times the derivative of the exponent. Derivative of negative 0.1x is just negative 0.1. That's a times sign. Oh boy, that makes it look really bad. Okay, so this is times a negative 0.1. Okay, all right, so that's the derivative of the exponent. All over the bottom squared. Okay, now the good news is this is going away because that's 0, right? And then what I would do is I've got 49 times this negative 0.1, all right, and then I've got minus this. So if I do this negative times this negative here, that's going to make the top positive number, okay? So I'm going to do this 10,900 times 49 times 0.1. But I know that it's positive, so I don't need all those negative signs. All right, so let me see what that gives me. So I got 10,900 times 49 times 0.1. So that gives me 53,410. So that's my numerator. 410, and don't forget the e to the negative 0.1x. So there's your numerator, and then your bottom is going to stay the same. Okay? All right, so there's your derivative, simplified. So everybody with me, we got a negative times a negative that made the top positive. Then I multiplied the numbers, 10,900 times 49 times 0.1, and I got this, okay? And then I had the e to the negative 0.1x. So that's your numerator over the bottom squared. So that's what I would use. Now I can find the rate. How fast is the population changing after 3 hours? So every hour is going to be different, right? The rate is changing at a different pace. So this is just for 3 hours. So we're going to plug in 3 here and 3 here, okay? Or you put this whole thing in your calculator and do it that way, however you guys want to do it. So I'm going to do 5,053, 410 e, and then negative 0.1 times 3. So there's my top number, 39,000, and I'm not going to round that, okay? So that gave me, some of you guys, I know on quizzes and tests, you're off a little bit. You email me about that. Remember, if you round ahead of time, you're going to get the wrong answer. You cannot round in math until the very last step. So whatever's in your calculator, you're going to leave that in your calculator, and you're going to use those numbers. You'll see what I do in just a minute. All right, so now I'm going to do the bottom. I'm putting in 3, looks like 31. I'll put 3 in there. Okay, so I've got 1 plus 49 e to the, let's do negative 0.3. And then I'm going to square that. So that gives me 1,391.2969. Okay, so I have to divide those numbers, okay? They're still in my calculator. So remember, you can just use your up arrows and get the numbers you want. So I want to do this number divided by that number without rounding. So I'm going to go up here, highlight that, hit enter, puts it there, and then divide it by, and then get that number, put it there, enter. So now that is an exact number, and I did not round. So now if they ask me to round, okay, now if they ask me to round, I will get the correct answer. So that's 28.439, and this said to round to the nearest integer. So that would be 28, since it's 0.4. Okay, so 28 bacteria per hour. And that's the rate. Okay. All right. So hopefully you are okay with that. Okay. All right, so it doesn't matter the type of problem you have. Again, just the words are real important right now. Okay, so if I asked you for the population at after 3 hours, that would have gone in the original function. How fast? That's a rate. So that's a derivative problem. Okay, last one I don't think is too bad. The function is not as bad. So this is asking us about increasing or decreasing. So remember that has to do with the first derivative. We've got to do our test points on the number line. So let's look at that, okay? All right, so we got to find the derivative of this function. So the derivative, this is a chain rule now. So the outer function is something squared. So remember, to do something squared, it would be 2 of whatever is in the middle function. Oh, that's -4, sorry. Let me do that again. All right, so we got 2 of whatever is here to the first power, we subtract 1, then times the derivative of the inside function. Well, the derivative of this derivative is 0, so I have to worry about that. But the derivative of e to the 2x is e to the 2x times the derivative of the exponent, which is 2. Okay, so that's my derivative. I definitely want to clean that up. So that's going to be 4e to the 2x times e to the 2x minus 4. So there's my derivative. Okay. So to find my critical numbers, I set each factor equal to 0 and solve. So I have to set 4e to the 2x equal to 0, and I have to set e to the 2x minus 4 equal to 0. Okay. Now on this side, I'm not going to get a critical number, because if you divide both sides by 4, 0 divided by 4 is still 0, and e can never equal 0. If you remember exponential functions, e to the anything is always above the x-axis. So that means there is no point on here where it's going to equal 0. Okay, so this one does not have a solution. But I can solve this one to get my critical number. So I will get a critical number over here. If I move the 4 over to the other side, I get a positive 4. Okay. If I now have to write this as a logarithm, so I'm going to take the natural log of the base, that equals that exponent, and then I'm going to take divide by 2. So I can't move that. So the natural log of 4 divided by 2, that's our critical number. Okay. Put that in your calculator, the natural log of 4, and then divided by 2, you will get approximately 0.693147. Okay, I'm not going to round too much, but that's basically what that is. All right, so now that goes on the number line. So we're going to look at the derivative, and our only critical number is this 0.69343147. Okay, so I need to pick a number less than that. I'm going to pick 0. Pick a number bigger. I'm going to use 2 and not 1 just so you can make sure you see that, but 1 is okay. All right, so we're going to put it in here, right? We're testing this in the derivative. All right, so I know if I use 0, if I put a 0 in here, 2 times 0 is 0. E to the 0 is 1. So this term is 4. It's positive. If I put 0 in here, e to the 0 is 1. 1 minus 4 is negative 3. So I got negative 3 times a positive 4. That's negative. So this side is decreasing. If I put 2 in the derivative, if I put 2 in here, this is definitely positive. Everything's positive over here. If I put 2 in here, 2 times 2 is 4. E is almost 3. So 3 to the 4th power is, and minus 1 is going to be a positive number. So we got a positive times positive on this side. So that means everything on this side is increasing. So this is where your function decreases. This is where your function increases. So f of x increases 0.693147 to positive infinity, and f of x decreases on the other side from negative infinity to 0.69. Now if they wanted an exact answer, I would put this. I would put this to infinity and then negative infinity to this, okay? You can put that in here instead of the decimal. So again, if it's a Hawks question and they don't want you to round, or if they do, you know, just pay attention and make sure you don't round too much while you're doing your work, okay? All right, so that does it for this section. So hopefully that's enough to get you going on your homework. Let me know if you need any help, and I'll see you back here next time.